This tutorial will explain the array sensor from CUNG with all its options. The array sensor is the perfect solution for the precise detection and tracking of objects in contrast differences. No matter if the application is about positioning of print marks, web guiding, or the monitoring of diameters, the array sensor from CUNG is the right solution due to its measuring proximity detection principle. Due to the high-resolution receiver array, the sensor is able to detect objects with an accuracy of down to 30 micron, depending on the detection distance. Like this, it is the perfect solution for applications where details matter. The array sensor is available in different versions. In general, there is a proximity and a retroreflective version available as a diameter or an edge detection version. The sensing range is either 25 or 100 mm. The proximity version automatically recognizes whether a reflector is in use or not and decides whether it will work in proximity or retroreflective mode. This avoids faulty operation and increases the operational reliability. There are some points that need to be observed with regard to mounting in order to increase the operational reliability even more. To avoid direct reflections, it is recommended to work with a lateral approach angle of 5 to 10 degrees. If thicker material like this coated wooden board needs to be detected, it is recommended to work with an approach angle of 2 to 3 degrees in order to avoid double switching at the edges, which come from reflections at the lower edge of the material. The angle needs to be in a way that the lower part of the object is shadowed. The array sensor detects the first edge of an object from the sensor's plug side. Depending on the actual position, the sensor shows an analog value between 4 and 20 mA. If the material leaves the detection area on the plug side, the sensor shows a value of 3.5 mA, and if the material leaves on the opposite side, a value of 20.5 mA is shown. If a sudden signal loss occurs, which may happen with a web break or if the sensor has no orientation, the sensor displays 3 mA. The very good visible LEDs show the following states. The green LED is the power LED, which is always on if the sensor is powered up. Yellow represents the digital switching output Q, which shows that an object is present. The array sensor is a cost-effective solution when comparing it, for example, with a camera system with a similar accuracy. It is one sensor for many different applications and materials. The sensor is easily and quickly mounted and is very robust against environmental influences, thus reducing machine downtime. An easy handling is guaranteed as there are no complex adjustments necessary and the commissioning is pretty easy. The visible white light spot helps to easily align object and sensor. Web guiding. This application is a standard application where the sensor needs to detect that a web material is in position. This material can either be opaque or transparent. If it is a transparent material, a reflector needs to be used. The sensor in this example is an AT20E with a sensing distance of 25 mm. The sensor is mounted in any position at a distance of 25 mm from the web, and the web is covering the light spot about 50%. If the web is moving, the current milliampere value is changing accordingly. If the web material is changed to a transparent film, it is necessary to use a reflector. If the reflector is placed under the light spot during startup, the sensor automatically detects the reflector and works in retroreflective mode. The accuracy in this combination is 30 micron. Diameter detection. In this application, the diameter of a glue line on a paper needs to be monitored. The sensor in this example is an AT20D with a sensing distance of 25 mm. The sensor is mounted from top and detects the diameter of the glue line. If the diameter is not changing, also the output stays constantly on the same value. If the diameter changes, the output milliampere value is changing accordingly.